Question number 2. Complete the table below by filling in the energy associated with each cell. So for these questions, all we have to remember is that the average energy per motion is 1/2 kT. And that R equals Kn, where N is Avogadro's number. So all you have to remember is that for molecules, if you see molecules, then we're going to be using kT. However, if we see moles, then we're going to be doing R. We're going to be changing, instead of using Boltzmann's, we're going to use R. So let's see. For the first question, translational motion for 10 molecules. So this is easy because for all molecules, regardless of linear or nonlinear, remember that there are three modes of translational motion. So we're just going to do 3 times 1/2 kT times 10 because we have 10 molecules. So this is going to be 15 kT. Okay, so for rotational, we remember that also for nonlinear molecules, it's 3. So now instead we have 5 moles. So this is just going to be 3 times 1/2 kT times 5. So this is going to give us 7.5 kT. But we're going to convert this to RT because this is talking about the number of moles, right? So we're going to have 7.5 RT for nonlinear molecules. So SF6 is also nonlinear. And SCN minus, this is going to be a linear molecule. So instead of multiplying by 3, remember for linear molecules, the rotational modes is only 2. So it'd be 2 times 1/2 times 5. So this is going to give us 5. Okay, so for vibrational modes, this, remember how we calculated it, is based on the total number of modes subtracted from the translational and rotational modes. Okay, so for the CH3F, we have a total of how many atoms? 5 atoms. So that's 3 times 5. So that's 15. Okay, so we're going to do 15 minus 3 for translational, minus 3 for rotational. So that's going to give us 9. So then we can do 9 times 1/2 times 9. And so that's going to give us 9 kT. Because we we're going to be doing 2, not 9. 2 molecules. Right, so this will give us 9. For SCN minus, it's linear, so we're going to have, well, there are 3 atoms, so 3 times n is what? It's going to be 3 times 3, so that's going to be 9. 9 subtracted from 3 translational, 2 for rotational because it's linear. That's going to leave us with 4. So we're going to have 4 kT. Okay, so for SF6, we're going to have 7, so that's 3 times 7, 21. 21 minus 3 for translational, 3 for rotational, so that's going to give us 15. Okay, so for BH2 minus, we're going to have 9 because 3 times 3. 9 minus 3 translational, 3 for rotational. This is a nonlinear molecule. We're going to have 3 kT. Okay, so for non-vibrational non-vibrational energy, all we have to remember is that for nonlinear molecules, it's going to be 3 RT. Okay, so because we have 3 times 1/2 for the translational, 3 times 1/2 for the rotational. So that's going to give us 3 kT. And since we're looking at the number of moles, that's going to be 3 RT. Now, since we have 3 RT, then for 6 moles, it's going to be 18 RT. Okay, so for all these nonlinear molecules, it's going to be 18 RT. Because for nonlinear, it's going to be 3 times 1/2 for translational, 3 times 1/2 for rotational. We're not including the vibrational. So that's going to give us a total of 3 RT. And if we have 6 moles, it's going to be 18 RT. Now for vibrational, it's going to be a little bit different because instead of doing 3 times 1/2 plus 3 times 1/2, we're going to now do 3 times 1/2 for translational plus 2 times 1/2 for the rotational, right? Because linear molecules only have 2 rotational modes. So now it's going to be 5/2 kT. And then since we're looking at moles, it's going to be 5/2 RT times 6. So that's going to give us 15 RT. Okay, now for the total energy, this is just going to be the total number of atoms times 3, right? Because 3N, right? So we have for CH3F, we're going to have 15. 5 times 3. 15 times 1/2 kT times 2, right? Because we have 2 moles. So in this situation, the 1/2 and the 2 can cancel out. So we're only going to be calculating the total, the 3 times N. So in this situation, we're going to have 15 RT. For this one, we have has 3 molecules. So this is going to be 9 RT. SF6 has 7, so this is going to be 21 RT. And then BH2 minus has 3, so that's going to be 9 RT.